We have seen that a function of two variables at the stationary point, if the Hessian is positive, then the function has an extremum. If the Hessian is positive. Well, and what happens if the Hessian is negative or when the Hessian is zero? If Hessian is negative, that means going away from the stationary point in different directions. Sometimes we go up, sometimes we go down. And this is called a saddle. You can think of the saddle at the back of a horse, which behaves like a minimum if you go in the direction from the head to the tail, and it behaves like a maximum if you go aside, to the left or to the right. Let me illustrate this with a simple example, with a simple function, fxy being x squared minus y squared. Well, looking at the function, I hope it is almost clear that this is indeed a saddle, because if we look at points where y is 0, then it has obviously a minimum. 0 at 0 and positive everywhere else. On the other hand, if we look at the points where x is 0, then this is minus y squared, and this is obviously a minimum. A maximum. It is 0 at 0, and it is negative everywhere else on this line, x is 0. So in one direction, in the xy plane, this is this direction, and in the xy plane, this is this direction. So in one direction it looks like a minimum, in the perpendicular direction it looks like a maximum, so this is a saddle. Well, and let us compute the Hessian to show that it will be negative. The derivative with respect to x is 2x, and the derivative with respect to y is minus 2y. Then the Hessian, which is the determinant of the matrix of second order derivatives, fxx, fxy, fyx, and fyy. Then fxx is 2, the mixed derivative is 0, and fyy is minus 2. And this is indeed minus 4. And yes, it is the case that when the Hessian at the stationary point is negative, then we have a saddle. Well, and what happens if we have 0 value for the Hessian at the stationary point? This tells nothing. It may well happen there is a minimum, it may well happen there is a maximum, it may well happen there is a saddle, but even other points. It may be a maximum for a function x to 4 plus y to 4. It may be, so this is a minimum. If we have minus x to 4 plus y to 4, we have a nice maximum. If we have x to 4 minus y to 4, we have a saddle. In all these cases, we have 0 Hessian and the stationary point, which is the origin in this case. But there are other types of points. One of them, what I like most, is monkey saddle. You can open Wikipedia and find monkey saddle. You have the formula of the function, you have nice picture, the graph of the function, because the monkey has 2 legs and a tail. And for a monkey to sit comfortably on a saddle, it must have 3 directions when it goes down, and in between three directions when the function goes up. So Hessian is 0 does nothing, and we must consider something more sophisticated. A good way is to plot the function using a computer, plot the graph of the function, or plot the contour lines. And extremum in contour lines is signaled by contour lines looking at as concentric circles. A saddle is characterized by a contour line that forms a cross like that. A monkey saddle would correspond to 3 crossing contour lines, with the other contours looking like that. So for us it is very important that the extremum occurs at a stationary point where the Hessian is positive, and then we look at the sign of these numbers to decide whether the extremum is a minimum or a maximum.